Today's video is on how to find the z-star values that correspond with confidence intervals. So the first question is, what is the z-star value for a 95% confidence interval? First, we'll look at a normal distribution. A z-star value is the same as a z-value, or a z-score. So we're going to look at a normal curve. 95 confidence means there's 95% in the middle of the curve. So we've labeled 95% of the area under the normal distribution with 95%. And if we want 95% in the middle, our goal is to figure out what is the z-score of each of these dotted lines. What z-scores are located at each of these dotted lines. And it's symmetrical. We want 95% in the middle. So if 95% is in the middle, then how much would be in each of the tails? Well, the whole curve is 100%. So we would take 100% minus the middle part of 95, which means there's 5% in each of the tails. And because the normal distribution is perfectly symmetrical, we can divide that 5% in both tails by 2 to get the percent in each tail. When we do 5% divided by 2, we get 2.5% in each tail. We can do a quick check that says 2.5 plus 95 plus 2.5 does equal 100. So it has to equal exactly 100, and then we know we've done it correctly. The area under the normal distribution is equal to 1 or 100% because it's a density curve. So we can check that we've calculated our tails correctly. We have 2.5, 95 in the middle, and then 2.5% on the end. Now you have two options. You can either use technology or you can use table A. We're looking for the z-score. So I've labeled here in orange, negative z-star value will be at this dashed line, and the positive z-star value will be at this dashed line. And they'll be exactly the same value, just one of them will be negative and one of them will be positive. Because the normal curve is symmetrical and it's centered, the z-score values are centered at 0 with a standard deviation of 1, those values will be exactly the same, just the opposite sign. So we've got the negative version and the positive version of the same number. Now you know we're looking for a z-score. That means the mean is 0 and the standard deviation is 1. In table A, you can use 2.5%, which means you'll be scanning the bulk of the table for a p-value of 0.0250. So that would be 2.5% written as a decimal. Notice I just moved the decimal 2 times to the left to make that number as a decimal, and writing the corresponding z-score by identifying the row and column that houses the cell that is closest to 0.025. So let's take a look. Here's our table of values, and we're going to look in the bulk of the table for 0.025. So we've got directions up here. We're looking for 0.025. The closest we come to is, this guy, exactly 0.0250. Then we're going to look at what corresponding z-score that is. So if we follow this pink arrow to the left, you can see negative 1.9 is the beginning of the z number. And if you follow up to the column, 0.06, that completes our z-score. So negative 1.96 is the z-star. That's the negative version. So that would correspond to this left orange z-star. So notice that we were looking for a p-value in the middle of table A. So we've worked a little bit with table A. So far we've been looking at z-scores on the outside and finding the p-value in the middle. This time we're starting with the p-value of 0.0250, and we're looking in the middle of the table. We're scanning for that number, and once we find it, we look at the corresponding row and column to build the z value from there. Now, this is the same exact z-score or z-value that you would get from looking at 2.5% plus 95%, which is 97.5. So if we add these two together, remember table A shows you the area to the left. So 2.5 plus 95 would give you 97.5, and that would be the area to the left of this dotted line. All the gray stuff plus this bonus white stuff. So if you did the same thing with this table and you looked in the middle of the table, it'll be on the other column, the other side, where the bigger numbers are. But you're going to look in the middle for 0.9750, and when you find that, you'll notice it's exactly at positive 1.9 and then 6. So it'll be a positive 1.9 on the left, and then 6 will be the column. And that'll match. You'll have a negative on one side and a positive on the other side. So our z-star value is going to be 1.96. We always record it as a positive. When we use it in the formula, we're going to use positive and negative version, so there'll be a plus or minus anyways, and we don't have to worry about the negative or the positive sign. So our z-star, we'll just report it as the positive version of that number. So once you get either one, the positive or the negative, we're going to use the positive version, so 1.96. Let's try it with technology. So without using table A, we could use the calculator. If you use the calculator, you would click on second distribution and then select inverse norm. The probability is going to be either that 0.0250 or that 0.9750. You can choose, and I've shown both here just to verify that they do in fact give you the exact same answer, just with opposite signs. So the probability goes first. The mean will be 0 because we're looking for a z-score, and z-score distributions always have a mean of 0 and a standard deviation of 1. So the mean is 0, the standard deviation is 1 every time, and then you're just going to change that probability number. And you can use that left tail probability, or you can use the sum of the middle and the left tail, and they'll give you the same value just with different signs. And our z-star is going to be the positive version. If you don't prefer working with the graphing calculator, you can also do this in Desmos, and it's using the inverse CDF function. So we'll just name D equal to normal distribution, and we don't have to type anything into the mean and standard deviation parts. It's default to 0 and 1, as you can see below. So it's really nice. You don't actually have to type anything into those parentheses. But if you're feeling nervous about it because you left them blank, you could type a 0, 1 into those, and that would work exactly the same. And then in the next cell, you would have to type d.inverse CDF, and that's our inverse norm function, which is the same as inverse norm in the graphing calculator. And then you can either put your 0.0250 or you can put your 0.975. Either of those, like I said, just like the calculator will give you the negative version of that number and the positive version of the same number. And again, we're going to report the positive as our z-star at the end of the day. So there's 3 different ways to find the z-star value. Let's do it one more time. We're going to do it with 90% confidence interval. So the same process, but this time we're going to do it with 90%. So again, we're going to start with our picture. Here's our picture. Our CL here stands for confidence level. So our confidence level is 90%. So 90% is going in the middle. We're going to do the same calculation. We're going to take our whole 100%, subtract that 90 that's in the middle, and we're going to get 10% for both tails. Since the normal distribution is symmetrical, we divide that by 2 and get 5% in each of the tails. We can do our double check. 5 plus 90 plus 5 is equal to 100, so we know we've calculated that correctly. Then we can look in table A. We can either use 0.0500, that's 5% written as a decimal, or we can add 5% to 90 and look for 0.9500 in the table. Both of those will give us the same number, just with different signs. So let's take a look at the table. Here's our standard normal table. We're going to scan the middle of the table where all the probabilities are, and we're going to look for either of those 2 decimals. In the chunk that I have screenshotted right now, we can see it's not exactly 5%. We have a 5.05% and we have a 4.95%. So we would ordinarily just choose the one that's closer to 0.05. With double zeros, but in this case it's split directly down the middle. It's actually exactly halfway in between. So we might as well be as exact as possible. We'll take the negative 1.6 from the left row, and then we'll just split the difference between 0.04 and 0.05. Halfway in between would be 0.045. So the best answer would be negative 1.645, kind of splitting the difference between 4 and 5 to do 4.5. Since those 2 values are the closest we can get, and they're halfway, they're directly in half. So that's the limitation with the table, is not every probability is listed exactly in this table, but we can get as close as we can, and that's a perfectly fine estimate. And then our final answer that we'll box will just be the positive version of that number. If you were looking for 0.9500, you would run into the same issue, but it would just be positive 1.6, and then you do the same for 5. Again, with technology, it'll work the same way. So you can do the inverse norm function and type in 0.05. You don't need the extra zeros. I just write them because that's how it's written in the table, but you don't need them in the calculator. And then 0 is the mean, 1 is the standard deviation. That's always true when we're doing z-star or anything z-score related. You can see here that the exact answer is negative 1.64485. So our 1.645 was a pretty good estimate, was rounded appropriately. And the calculator does give you a much more exact value for that. You can see here that 0.95, that 95% gives you the same value, just the positive version. So you can do either one. You don't have to do both, but doing both is kind of nice. It verifies that you've set up your normal curve correctly. We can also do the same thing in Desmos. So you can type the exact same beginning. D is the normal distribution. You can leave your parentheses empty or type a 0 and a 1 into the parentheses. And then when we do our inverse CDF or the D function, which is already labeled as the normal distribution, we can type in 0.05. And again, those extra zeros are unnecessary. Or we can do 0.95. And both of those will give us the same answer as well. Sweet. Thanks for watching. See y'all in class.